Hey, this is Kyle, and I'm going to be going through part C of homework 2, in which we will numerically demonstrate that for a given average and standard deviation, that when we maximize the entropy function that we just derived in the last part, it will show the normal distribution. And as I talked about in the last video, the expression for entropy we calculated was a negative summation of a probability times the natural log of that probability. And since we're going to be showing this by maximizing that function, it'll just be simpler to minimize the positive value for that equation. So it'll just, that way we can use a minimize function. So first, I'm going to make a function for our entropy function. So we'll define entropy, and it takes in a probability for each grade, basically. And we're just going to define that with the equation I just derived. So we'll do np dot sum of the probability times np dot log, and Python defaults to log base e, so np dot log of the probability, and then we'll return. Alright, and now we'll get into our grades, so number of grades. Since we're going to be taking a look at a distribution, I'll do like 101. That way there's more to see than just with like 10 grades. And like I said, we're going to be minimizing our entropy function, so we can get into that. So we'll do minimize, and our function, our function is going to be the function we just made for entropy. And then our x0 will be our initial guess. So we'll actually make an array here for the actual grades themselves. We'll just call it G. And we're going to make this the same size, or sorry, not the same size. We'll make it from 0 up to our number of grades. So there will be 101 elements in it. And it'll go from 0 to 1. Let me comment this out real quick. Or 0 to 101. So we take a look at G. It'll just be each possible grade that a student could get. We'll bring this back. Alright, so as I was saying, we're going to need our initial guess, and for our initial guess, we'll do p naught, and that we're going to want to make an array, and we'll just fill it, and again, we're going to want to make that the same size as our n grades, or 101 elements, and we'll fill it with whatever we want to make our initial guess, which we'll just call 0.01 for the probability of each grade. And then we can just set this x naught equal to p naught. Alright, and then the next thing we want to put in our minimize function, we're going to want to give it bounds. So our bounds, we're going to want to be from our 0 to our final value, so it'll be 101. And we can do this by setting bounds of 0 to 1, and then just multiplying by the value we want to be our maximum, so n grades. And then the last thing we want to feed our minimize function is constraints to minimize the function with. So the first one we'll take a look at is that obviously anytime you're working with probability, the total probability has to equal 1. So if I scroll down to constraints here, constraints, we're going to feed it a function, feed the constraint function, and then give it a type. So EQ is the one we'll be using for equality. So as I said, we give it a type, and we'll be using equality, and then we also give it a function, and our function is going to be our first constraint, which, as I mentioned, it's going to be our total probability. So probability P is the sum of all the individual grade probabilities. So we'll do NP, and we'll just return this because that's all we need. NP.sum of all the individual probabilities, and so that's going to be 1, as I was saying. But our constraints in our minimized function we want to be equal to 0, so we'll subtract 1 here. And that. And then the function is prob, I just named it. You gotta go. Too many values to unpack. This function is entropy. Oh, I put that bracket in the wrong spot. Get rid of that. Shoot with the bounds. Alright, there we go. Alright, so now we're given a probability of each grade. So it looks like it's about just under 1% chance. So now if we store this minimization function as a variable, we'll just call it like students or something like that. We can make a figure, so figure equals mig subplots, and we'll make a bar graph. So figure add bar, and we care about those x values that the minimize function was returning. So we want figure.add bar, and we want our x values to be our grades, and we want our y values to be the returns from our minimize function, so student.x. Now if we take a look at this, it's just uniform, which makes sense, as we've only given it the one constraint that the sum of probabilities has to equal 1. So if we want to get this to look a little better, we want to give a given average and a given standard deviation, and then maximize the entropy based on that. So that's 2 more constraints that we're going to want to add. So I'll define 2 more functions. One we'll call just average, average. So the average grade is going to be the probability of a grade multiplied by the grade. So average will be P times the grade. And then again, we want it to be 0, so we'll subtract whatever we want the average to be. So we'll say the average is 50. And then we'll define a function called standard deviation, takes in P. Now this one we want to use the equation for standard deviation, so we'll return the square root of, well, let's see, 4 standard deviation. So it's going to be the square root of the sum of the data point, but minus the average squared. Alright, so square root of p times the average, which we'll have to define locally. P times the average. Sorry. Back here. NP dot sum of each data point minus the average, so P is the average second power. Alright, and then we're going to want to add those constraints in down here. And then we want standard deviation. And now we'll have to do the same thing here, so since we want this to be 0 as well, we'll just say minus what would standard deviation be, we'll call it 10. And then let's take a look. Give me 1 second. Alright, so I had a little error in my my functions up here. We're actually going to want to take the sum of our probability times each individual grade to get our average grade. And then similar thing down here, I actually didn't use the equation correctly, so we want to do the individual grade minus the average grade. And then that's what we're going to multiply the probability by. So we'll do our individual grade minus our average that we just made. And then raise that to the power of 2, multiplied by probability. We'll rerun our functions. I think I'm missing a parentheses. Right there. Alright. Now we have all our constraints defined. Our average is a 50 with a standard deviation of 10, and our sum of the probabilities is going to be 0, which is always true. I'll take a look at this. Positional argument follows. Positional argument follows keyword argument. This is a new one. Let's see. Take these out for a second. Should just let me add in another constraint. And then standard depth. Not sure why it is not letting me do this. Alright, let's take a look at constraints. Separating multiple constraints. Minimize. Alright, I had to take a long look at that, and I forgot that I had typed an extra minimize here when I was looking at the parameters for the function. I didn't even see it. Alright. Now we're good. Alright. So now if I remake the graph, that does not look like it should. Oh, okay. Forgot to sum the average in the standard deviation function. That would definitely help. And look at that. So now it clearly shows that it follows a normal distribution. And the way we made that was just by minimizing our entropy function that we derived in the previous part. So looks pretty good.